In the northern hemisphere, December has the fewest hours of daylight and the most darkness, because at that time the tilt of the Earth's axis is pointing the northern hemisphere away from the sun. However, as counterintuitive as it might sound, December actually has the longest days of the year. Modern clocks, of course, think every day is 86,400 seconds long, but that's just the average length of a solar day over the course of the year. A solar day is what you actually measure with the sundial, or equivalently, it's the time it takes for a line of longitude on the Earth to rotate back to face the sun again. This actually requires slightly more than 360 degrees of rotation because the Earth isn't just sitting in space rotating. It's also moving around the sun, so it has to rotate roughly 361 degrees before the sun comes back perfectly overhead a particular place on consecutive days. If the Earth's orbit were perfectly circular and its axis were perfectly upright, that would be the end of the story. However, the Earth's orbit is elliptical, so sometimes the Earth is slightly closer to the sun, and the peculiarities of gravity mean it moves faster when it's closer to the sun, so it goes farther around the sun in 24 hours. So the Earth has to rotate slightly farther before the sun comes back right overhead. 0.033 degrees farther, to be precise. More rotation takes more time, so when the Earth is closest to the sun, the real sundial measured day length is lengthened by about 8 seconds. Plus, the Earth's axis is tilted, which is what gives rise to the seasons, but also means that at the time of year when the tilt points towards or away from the sun, narrower slices of longitude are aimed directly at the sun. So as the Earth moves in its orbit, it has to rotate slightly farther in order for a particular line of longitude to catch up with the changing direction to the sun. 0.088 degrees farther, to be precise. And again, more rotation takes more time, so when the Earth is tilted towards the sun, the real sundial measured day length is lengthened by about 21 seconds. Now, by a strange coincidence, we live during a time in geologic history when the Earth's closest approach to the sun happens almost perfectly to coincide with one of the 2 times of year when the Earth's tilt is oriented directly towards the sun. So these 2 day lengthening effects add up, and on December 22nd, the length of a solar day as measured by a sundial will be the longest it is all year, 86,430 seconds, for a grand total of 30 extra seconds. Oh, and in case you're wondering where those 30 extra seconds on December 22nd go, well, they get pushed into December 23rd, and the extra seconds from the 23rd get pushed into the 24th, and so on, which is why solar noon, or the time that the sun is directly overhead, shifts about 30 seconds later every day around the solstice. This increasing disparity between solar time and clock time is also why in the northern hemisphere, the earliest sunset happens a few weeks before the solstice, and the latest sunrise happens a few weeks after.